So we started off last week, we were doing the percent concentration. So I just want to do a quick review of that to see if you remember those processes. And let's say we have a weight in weight solution, and it is a 12% weight in weight solution. So we want to ask how much serum to mix with 440 milligrams of saline, of sterile water, to create a 12% weight in weight solution. Now, it's very important in this case that it's weight in weight. Because remember, if it is volume in volume or weight in volume, we have to talk about the total. The amount of the saline is not necessarily, they're not additive, if you recall. The amount of saline plus the amount of serum does not equal the amount of volume of the total. So weight in weight, however, the two weights do add together to make the total weight. However, here the 12%, 12 out of 100, what does the 12 represent? That's the amount of serum, or the amount of the medication. The 100 represents the total solution. Very similar to the dilution ratios that we talked about 2 weeks ago. Well, do we know the amount of serum? No, we're looking for the amount of serum. Do we know the total solution? No, we don't. But a percent is still a ratio, just like a dilution ratio was. And every time we look at a percent, there's another percent that's implied. 12% is the amount of the serum. Now, since this is additive, the other 88% is the amount of the saline, or the sterile water that is added. So we have 440 milligrams of saline. Cross multiply and divide. 100 times 440 divided by 88 gives us 500 milligrams. So the total solution is 500 milligrams. We still need to know, we're asked how much serum are we going to put in there. Subtracting the 440 milligrams of saline, there's 60 milligrams of whatever that medication is. Any questions on that one? Now remember, weight in weight is the only type of concentration where that'll work, because the other ones are not additive. For example, let's say how much serum again to make 300 milliliters of a 35% volume in volume solution. Notice in this one, I gave you 300 milliliters of the total solution. Because when we're talking volume in volume or weight in volume, volumes do not necessarily add up, because we talked about the particles hide between the particles of the other material. So in a volume in volume, 35%, of course, is 35 out of 100. The 35 is the serum, and the 100 is the total solution. And we are looking for how much serum. We're looking for the amount of serum. And we do have 300 milliliters of total solution. So now we can cross multiply and divide. 35 times 300 divided by 100 is 105. And of course the units have to be the same, so it's 105 milliliters. Look familiar? Okay. Then one of the other things, we talked about doing the syringes, which we're not going to get into. But then we talked about dosage calculations. Things like, let's say the orders are 1,000 milligrams of, let's just say ibuprofen. And on the label of the bottle, it's 400 milligram tablets. We'll assume they're scored so that you can cut them in half. So we're going to round once again to the nearest half tablet. So our formula, the amount to administer, was equal to the doctor's orders divided by the on-hand dose times the vehicle. The doctor's orders in this case is 1,000 milligrams. Now the on-hand dose and the vehicle are kind of confusing. The big thing we know is that the on-hand dose must have the same units as the doctor's orders. So in this problem we have the 400 milligrams, which is the dose that is on hand. And then the vehicle is what carries the on-hand dose to the patient. So what carries the 400 milligrams to the patient? Excuse me. What carries that 400 milligrams to the patient? One tablet. Very good. So now we divide out. The milligrams divide out, which has to happen. The doctor's orders and the milligrams have to have units that divide out. 1,000 divided by 400 is 2.5 times one tablet is 2.5 tablets. So what you would administer to the patient is 2.5 tablets. Now, similar to that, you might have orders for one of those days for everybody. You might have orders for 30 milligrams of medication. And on the label, it says it is concentrated 2 milligrams per 5 milliliters. Usually written like this, 2 milligrams in 5 milliliters. So, doctor's orders are 30 milligrams. Now the on-hand dose is usually pretty easy to find because it has to have that same units of milligrams. So that'd be the 2 milligrams. And then what carries the 2 milligrams to the patient? 5 milliliters. So milligrams cancel. 30 divided by 2 is 15 times 5, 75 milliliters. So you would administer 75 milliliters of that liquid medication to the patient. So the doctor orders 1,000 milligrams of this medication. The label is 300 milligram tablets. These are scored, so round to the nearest half tablet. Go ahead and in your notes quick, find the dosage that you would administer to the patient. So what's the doctor's orders? 1,000 milligrams. On hand, 300 milligrams. Times vehicle, 1 tablet. We divide that out, we get 3 1/3 tablets. That's between 3 and 3.5. Which is it closer to? 3.5. Very good. So the nearest half tablet, that is 3.5 tablets to be administered. Any questions there? I found on a problem like that, usually the biggest mistake is made in the rounding. People round to 3 because it's less than half. Well, but you're rounding to the nearest half, not the nearest whole. Let's say we have an orders for 200 milligrams of medication, and on the label, it is 5 milligrams in 2 milliliters. Again, find the amount to administer to the patient. Okay. Doctor's orders. 200 milligrams. On hand. 5 milligrams. Vehicle. 2 milliliters. So divide out 200 divided by 5 is 40, and the units divide out, so it's just 40 times 2 milliliters is 80 milliliters. How many of you had both of those correct? Okay, does anybody have any questions on either one of those, on how they work? Okay. Well, we bring that up because that's going to be where we start out today, is we're going to talk about more dosage calculations with our new material. This was the dosage calculation formula. I'm going to talk about 2 other methods for calculating dosages, both of which I like better than the formula, but there's one that I have an obvious preference for. And we mentioned them a little bit last time. There is the proportion method. And in the proportion method, we start with the label, and we use that to go to a comparison of the doctor's orders to what is administered. And not always in that order. It might be administered over doctor's orders, might be doctor's orders over administered. So looking at that previous example, if we had orders for 200 milligrams and a label that said 5 milligrams in 2 milliliters. Remember, a proportion is just 2 ratios. So our first ratio is going to be whatever's on the label, the concentration on the label. 5 milligrams in 2 milliliters. So in a proportion, on the other side, the units are going to be the same. So milligrams on top, milliliters on bottom. Just like over here. So the doctor's orders of 200 milligrams have to go with the milligrams, have to go on top. And we're going to find what we're going to administer here in the milliliters by cross-multiplying and dividing. So 2 times 200 is 400, divided by 5 is 80. Now you notice I left the units out. They do work out. It would be milliliters times milligrams, then divided by milligrams, so the milligrams divide out, leaving us with milliliters. But that's kind of confusing, so I'm just going to leave them out.
So are these methods just kind of like what our preference is?
Whatever your preference is,
Okay,
yes.
so you're showing us 3 different things
Yes.
to get the same answer.
Exactly.
Okay.
Now, one of the limits of the proportion method, which is similar to the limits of the dosage calculation method, is you can only do 1 step at a time. The third method I'm going to show you, which is the dimensional analysis or unit conversion method, you can do several steps all at once in a big long string if you want to. So the doctor orders 1,000 milligrams of medication. The label is 300 milligram tablets. Once again, scored, so the nearest half tablet. Now, obviously, this is identical to a problem we did a few minutes ago, but we're going to do it with the proportion method. We're going to start with the label. 300 milligram tablets is 300 milligrams per 1 tablet. Now, on the other side, milligrams are going to be on top, tablets on bottom. Because it's a proportion, the units stay the same. Now, doctor orders 1,000 milligrams. That has to go with the milligrams. So right there's the 1,000 milligrams. And we will cross multiply and divide. 1 times 1,000 is 1,000. Divided by the 300 is 3 1/3 tablets. And of course, this is where you would do the rounding. 3 1/3 rounds to 3 1/2 tablets. Any questions so far? So let's have you try a unique one. Let's say the doctor orders 300 milligrams. And the label is 12 milligrams per milliliter. In your notes, I want you to try to do the proportion method. Find out what would you administer to the patient. So, what are we going to start out with? Start out with the label. 12 milligrams per milliliter is 12 milligrams per 1 milliliter. So on the other side, we have milligrams and milliliters. Doctor's orders of 300 go top or bottom? Top with the milligrams. So we cross multiply and divide. 1 times 300 is 300. Divided by 12 is 25 milliliters. Let's do one more of those. So let's say the doctor's orders are for 70 milligrams. And the label states 4 milligrams and 15 milliliters. Have you tried to figure out what are we going to administer to the patient there? So where do we start? The label, 4 milligrams in 15 milliliters. Now, if you did that upside down, it doesn't make a difference. It'll still work out. On the other side, milligrams, because there's the milligrams and milliliters here. If you did it 15 milliliters per 4 milligrams, it'd just be upside down. So we have the orders of 770 milligrams. It's going to go on top with the milligrams. Then we cross multiply and divide. 15 times 70 is what? 1,050 divided by 4. 262.5, is that correct? Perfect. Any questions? So that is the proportion method. And the proportion method is nice and simple because all you have to do is write down this ratio that is on the bottle. And boy, everything else has to line up. The units have to be the same on top on both sides and on bottom on both sides. So everything plugs right in. The problem is, like I said, and similar to the dosage calculation formula, you can really only go one step at a time. So the next method I show you is just way more versatile. It is, the official word is dimensional analysis. If you had a high school chemistry class or physics class, you probably saw that hit pretty hard. But basically, all it is our unit conversion process for converting measurements from our last unit. So back to a familiar problem here. So the doctor's orders are 200 milligrams, and the label is 5 milligrams and 2 milliliters. When we do the dimensional analysis, we start with the doctor's orders, and we convert to what we're going to administer to the patient. So it helps to know what units it is that we're going to administer to the patient. Well, we're going to administer to the patient here in milliliters. Now the doctor's orders may already be a rate or a ratio. If not, we turn them into a ratio or turn them into a fraction by simply putting them over 1. In this case, the doctor's orders is 200 milligrams. We turn that into a fraction by just putting it as 200 milligrams over 1. And now we need to convert milligrams into milliliters because we're going to administer the dosage in milliliters. I'll keep my information there. So we're multiplying by a conversion factor, a unity fraction. We're getting rid of milligrams. So over in this fraction, where do the milligrams have to go? Top or bottom? Bottom, so that they will cross-cancel out. And we have an equivalency that relates milligrams to milliliters. So milliliters are going to go on top. And we have 5 milligrams in 2 milliliters. Now notice, normally we would write that as 5 milligrams over 2 milliliters, but we had to write it upside down because that's where we need it to cancel out the right units. So it's the units that determine where things go, not just the simple ratio. What this is really telling us is that 5 milligrams of medication is equal to 2 milliliters of the solution. So the milligrams do cancel out. We've got 200 times 2 milliliters is 400 milliliters. 1 times 5 is 5, and that divides out to be 80 milliliters. So we would administer to that patient 80 milliliters of medication. So back to another standard problem we've done here. Orders 1,000 milligrams of medication. The label is 300 milligram tablets. And you probably guessed it, they are scored. So round the nearest half tablet. So using the dimensional analysis or the unit conversion, we're going to start with the doctor's orders, 1,000 milligrams. Now again, that is not a rate or a ratio, so we're going to turn it into a fraction by putting it over 1. In our conversion factor, we know that milligrams have to go on bottom because we're trying to cancel them out. Our relationship, 300 milligram tablets. That means 300 milligrams equals 1 tablet. So 300 milligrams, 1 tablet. So the milligrams cancel. 1,000 times 1 tablet is 1,000 tablets. 1 times 300 is 300. We divide that out, and it is 3 1/3 tablets. Scored, so we round to the nearest half. 3 1/2 tablets. If nothing else, it's good to see we get the same answer with all 3 methods, right? Okay, so let's look at a problem that is slightly different. Okay, let's say that we have orders for 500 milligrams, and the label is 4 milligrams in 25 milliliters. So again, we always start with the doctor's orders, 500 milligrams. Now once again, that's not a rate or a ratio, so we're going to put it over 1. We're multiplying by a conversion factor. And in the conversion factor, we have this equivalency. 4 milligrams in 25 milliliters is the same as saying 4 milligrams equals 25 milliliters. Which one of those is going to go on bottom? The 4 milligrams on bottom, so that they cancel out. 25 milliliters on top. Milligrams will cancel. 500 times 25 is going to be 12,500 milliliters. Over 1 times 4 is 4. And we divide that out, we get 2,125 milliliters is administered to the patient. Okay, so let's say our doctor orders 150 milligrams. Label states 3 milligrams in 2 milliliters. Find out how much is administered to the patient. In your notes, figure that one out. Okay, so where do we start? Doctor's orders, 150 milligrams. What do we have to do to that? Put it over 1. And then multiply by? Okay, we know the 3 milligrams has to go on bottom so that they can cancel out. And then 2 milliliters would be on top. So they cancel. Then what? 150 times 2, 300 milliliters. 1 times 3 is 3. That divides out to be 100 milliliters. Okay. We might have orders for 7,000 units of a medication. The label states "500 units per milligram and 2 milligrams and 5 milliliters concentration." This is what I had mentioned about the other two methods only being able to go one step at a time. Dimensional analysis can go several steps at a time. We're still starting out with the doctor's orders, 7,000 units. We'll make it a fraction by putting it over 1. Now in the first conversion factor here, we know we have to have units on bottom. We have to get rid of units. The only thing we have that equates units to anything else is what? 500 units per milligram. So 500 goes on bottom. What's going to go on top? Milligram, but how many of them? 1. 500 units per milligram means 500 units per 1 milligram. So now the units cancel out and we have milligrams. In our next step, milligrams have to go on bottom so that they will cancel out. And what do we have relating milligrams to anything else? You got it. 2 milligrams in 5 milliliters. So now the milligrams cancel out. On top, we've got 7,000 times 1 times 5 milliliters is 35,000 milliliters. 1 times 500 times 2 is 1,000. We divide that out, and we are at 35 milliliters. So we can go through 2 steps of the conversion at the same time. If we were doing the dosage calculation formula or the proportion method, we would have to go through the process twice. Now let me show you how I'd do that. So a two-step problem like this, I would always use the dimensional analysis. You could do it either way if you want to, and I'm going to show you how to do it with the proportion and with the dosage calculation formula right now. With the proportion, first step we have to do is figure out which of these labels with these concentrations we're going to use first. Well, our orders are in units, so we have to use the one that contains units. So it's 500 units per milligram. 500 units in 1 milligram. So on the other side, it's going to be units and milligrams. Doctor ordered 7,000 units. So we cross multiply and divide, giving us 14 milligrams. Now we have to take the 14 milligrams and go through this again. 14 milligrams. Oops, sorry. What conversion do we have that contains milligrams? That's the 2 milligrams in 5 milliliters. So 2 milligrams in 5 milliliters. On the other side, we have milligrams and milliliters as well. And we have 14 milligrams is what we got when converting the doctor's orders from units to milligrams. So now here we will cross multiply and divide. 5 times 14 is 70 divided by 2 is 35. So 35 milliliters. You get the same answer, but you can see this is much more tedious. Trying to figure out how to set it up, what to start with is really kind of a pain. The dosage calculation formula is even worse. If I were using the dosage calculation formula, I would have the 7,000 units ordered over 500 units. The vehicle will be 1 milligram. This cancels. That divides out to be 14 times 1 milligram is 14 milligrams. And then you'd have to run the 14 milligrams in over 2 milligrams in 5 milliliters. Milligrams cancel. 14 divided by 2 is 7 times 5 is 35 milliliters. So again, really tedious, but it's possible. Now, if any of you decide that you really like the dosage formula or the proportion method, let me know. And next week when I do examples, I'll try to concentrate on, make sure I use some examples with each of those methods. Right now, I'm going to concentrate on the dimensional analysis for the next hour or so at least, and we'll go from there. So let's look at a label. That's going to say on the label, constitute to 12 milligrams per milliliter with 4.5 milliliters sterile water for injection. Let's see here. So looking at this, what this is a vial that contains the concentrated medicine, the serum, in the vial. But you're not going to deliver it to the patient in that form. You're going to dilute it. What are you going to dilute it with? 4.5 milliliters of NS, of sterile water. The part of this label that we want is what? 12 milligrams per milliliter. Once this is constituted, it will be 12 milligrams per milliliter. So let's say the doctor's orders are 600 milligrams. So let's figure out what we're going to give to the patient. Where do we start? Doctor's orders, 600 milligrams. It's not a rate or a ratio right now, so we make it into a fraction by putting it over 1. What are we going to multiply by? Okay, the milliliter and milligrams. I usually start with the bottom number because I know that has to be the same as this unit. So milligrams go on bottom. And it is 12 milligrams per milliliter, so 1 milliliter. And we can cross cancel the milligrams. So 600 times 1 milliliter is 600 milliliters. 1 times 12 is 12. We divide that out. 600 divided by 12 is 50 milliliters. So we're going to administer 50 milliliters of medication. So let's say we are going to constitute 4 milligrams per milliliter with 23 milliliters of saline and the vial contains 100 milligrams of medication. So, doctor orders 300 milligrams. In your notes, try to find what are you going to administer to the patient here. Okay, so we're going to start out with what? 300 milligrams over 1 times, well, we know what has to go down here. Milligrams. What we want out of the label is the 4 milligrams per milliliter. So 4 milligrams per 1 milliliter. Milligrams will cancel, and 300 times 1 milliliter is 300 milliliters. 1 times 4 is 4, divides out to be 75 milliliters.
Maybe a stupid question, but
Yep.
on the labels of both of these, the first one is 4.5, this one is 223 or whatever.
Yep.
We don't do anything with that?
No.
Oh, okay.
It's all extra information.
Okay.
All we care about is the final concentration.
Okay.
Remember, we talked about how the volumes and stuff are not additive.
Okay.
The water, the saline that we put in there, technically, if this is a 4 milligrams per milliliter, that means that this is going to be 25 total milliliters if it contains 100 milligrams, right? But we only put in 23 milliliters of water. The rest of that's the medication that makes up the volume. So we really can't predict the amount of water, the saline that we put in there. We cannot use that to predict the concentration of the medication at all. So yeah, we have constitute 2. It has to tell us what the final concentration is going to be. So let's say that we are given anybody remember the grains per gram? One gram is how many grains? How many grains? Come on. I kind of blacked out on it too myself. That's kind of why I'm asking. 15 grains. I couldn't remember if it was 15 or 60. It's 60 milligrams per grain and 15 grains per 1 gram. So if we are given, the doctor orders 60 grains of medication. The label states "10 milligrams in 4 milliliters." We have a lot of issues to deal with here. We are going to start out with the doctor's orders, 60 grains over 1. But the vial says nothing about grains, it says milligrams. Well, the only thing we can do with the grains is we can get rid of it. Now, I really don't want to go from grains to grams, do I? I want to go from grains to milligrams. 1 grain is 60 milligrams. So 1 grain, 60 milligrams. So now the grains have canceled out. In my next fraction, I have to get from the milligrams now to milliliters. 10 milligrams and 4 milliliters. So the milligrams are now gone. So on top, 60 times 60 is 360 times 4. 1,440 milliliters are the only units left on top. And on bottom, 1 times 1 times 10 is 10. That's going to divide out to be 144 milliliters. So you can see this formula, the dosage or the dimensional analysis allows us to take several steps at once. It is time for a break, so let's do that. Let's come back and lecture we'll start lecturing again at 11:31.